Hello everyone, welcome back to my channel. This is Hista here. Today we're going to be seeing introduction video to chapter number 8, quadrilaterals. So this is part 2 of this introductory video. Previous session we saw the introduction part 1. If you haven't checked that out, please go to my channel and watch it. And we've explained all the topics of this chapter in detail. And today we're going to be completing this whole chapter's concepts. So let's get started then. We're going to be seeing two simple theorems, okay, and two very important theorems as well, right? So because one whole exercise 8.2 is based upon these two theorems, okay? So that's what we're going to be seeing today. So let's get started. Now, theorem 8.9, that is the midpoint theorem, is our first theorem we're going to be covering in this session. So what does it say? The line segment joining midpoints of two sides of a triangle is parallel to the third side of the triangle and is half of it. Now, first let's draw a triangle, right? First, we always need the figure. Okay, I have a triangle, name it as A, B, C. Now, it's saying the line segment joining midpoints of two sides. So we need to get the midpoints of two sides, right? So let's say the midpoint is D here and the midpoint is E here, okay? And now I need a line segment that joins these 2 points, D and E, right? So this line segment DE joining midpoints of two sides of a triangle, that is AB and AC has a midpoints D and E, and the line segment DE is joining these midpoints. Clear? This line is parallel to the third side, meaning it's parallel to BC and is half of it, meaning in other words they're saying that DE is parallel to BC and DE is equal to half of BC. That's what they're saying, right? If this line segment is parallel to this line segment, that means D is parallel to BC and is equal to half of it, meaning DE is equal to the half of BC. Clear? So obviously this theorem has a proof to it, but you don't need to learn the proof, okay? So far in the year of 2021 to 2022, that's what we have got. You don't need to learn the proof and all, but you just need to understand. So it's better if you pay attention and listen to what I'm saying here. It's very important. Don't skip this part. I mean, don't forward the video and miss this part. It's very important that you learn it, right, for your own understanding. Theorems must be understood, not just mugged up or anything like that. Okay, so now we are going to be seeing the proof to this theorem, right? So what do we need to prove? Exactly what I've written here. D is parallel to BC and D is equal to half of BC. And for this, we are going to do a small construction. What we're going to do? So we are going to extend point E such that DE is equal to EF. Okay, let's see what's that. We're going to extend point E and we are going to extend point C also, but we're going to extend it like upwards like this. Okay, where these two lines, that is from point E and point C, meet at point F. Okay, so we're going to do the small thing. So we need to extend point E and C such that they meet at F and such that DE, okay, let's just use another ink. DE is equal to EF. Okay, so that is here E is the midpoint of DF. Clear? Okay, now we need to join CF also. Let me just join it here. Remember very important thing, given that DE is equal to EF. Remember that. Okay, now let me just write what you have to write here in construction. Extend point E and C such that they meet at point F and such that DE is equal to DF. Okay, now let me just write this given below here. Okay, so given, what is given? DE is equal to EF, we know, and also DE, D and E are midpoints of AB and AC. See, this D is equal to EF by construction, we have told that, right? And D and E are midpoints of AB and AC. When I'm talking about midpoints, points, or angles, sides, and all, please keep looking at the figure so that you'll understand. Clear? So let's see how to prove that DE is parallel to BC and DE is equal to half of BC. Okay, so proof is in triangle ADE. Where is triangle ADE? ADE. ADE and triangle EFC. That is this triangle EFC. Okay, these two triangles, we are going to prove that these two are congruent to each other. Why? Means you will find out. 1 second. Okay. Okay, so let's see how we can prove that they are congruent. First, we can say that angle AED is equal to angle EFC. Okay, let's name these as angle 1 and 2, not angle EFC, by the way. It's angle FEC. Okay, sorry, that was a mistake. Angle FEC. Let's name these angles. So angle, this is 1, this is 2. So that is angle 1 is equal to angle 2. Why is it? Because it is a vertically opposite angles. Clear? Now DE is equal to EF. We are told here, right? DE is equal to EF by construction. Also, we can say that AE is equal to EC. Why is it? Why is it? Look at what is given here. Look at what is given here. What is given here? What? That E is the midpoint, right? So that is why A is equal to E. Exactly. So E is the midpoint. So which congruency rule are we using here? We are saying that triangle ADE, triangle ADE is congruent to triangle EFC. By which congruency rule? By SAS congruency rule. Clear? Also, why did we prove that these two are congruent? Because we want to say by CPCT that AD is equal to CF. Where is AD? Where is CF? Let me highlight that for you. AD is equal to CF. Okay, AD is equal to CF. Okay, I'm not able to highlight it. I don't know what's the problem. Okay, let me just use this. AD is equal to CF. AD is equal to CF. Clear? So that's what we want to prove here. Now, let's see what is the next part. AD is equal to CF by which rule? CPCT. We all know that, right? Now, so also we can say that AD is equal to also AD is equal to DB, because why? D is midpoint, right? D is midpoint. I'll write the rest of this proof here. Okay, I'll write it in this space. So let's use another ring. Another ink so that you won't get confused. Okay, so now we said that AD is equal to DB because D is the midpoint, right? And so therefore, can I say that BD is equal to CF? BD is equal to CF. How did I arrive at that conclusion? Because if I can say that AD is equal to CF, and if AD is equal to DB, so instead of AD, can I substitute a DB there, right? So that's why I'm able to say that DB is equal to CF. Clear? Now, also I can say that since I proved that triangle AD is congruent to triangle EFC, I can say that by CPCT, angle A is equal to angle C. Angle A is equal to angle C. Okay. Also, you can, okay, not this angle C. Just 1 second. I'm not talking about angle ACB. No, I'm talking about angle ACF. Okay. So that means this angle. And also, you can say that these are alternate interior angles. Also, these are alternate interior angles. Okay, so now can I say that AB is parallel to CF? Since angle A and angle C are alternate interior angles, AB is parallel to CF. Okay, and also I can say that DB is parallel to CF, since AB is equal to DB, right? So DB is also parallel to CF. So thus I can say that DBCF, look at the figure, DBCF is a parallelogram. DBCF. This is a parallelogram. Why? Because DB is equal to CF. Here we said DB is equal to CF. Also we said that DB is parallel to CF. We had studied in the previous session, in previous theorem, that if a pair of opposite sides are equal and parallel to each other, then the quadrilateral is a parallelogram. Exactly, right? So DBCF is a parallelogram. Now, since DBCF is a parallelogram, DF is parallel to BC. Okay, DF is parallel to BC. If DBCF is a parallelogram, DF is parallel to BC. And also I can say that, what can I say? DE is parallel to BC, right? DE is parallel to BC, because here I know that E is the midpoint, since D is equal to EF. So thus I can see that DE is also parallel to BC. If DF is parallel to BC, then half of DF, that is DE, will also be parallel to BC. So again, we are seeing here that DBCF is a parallelogram. Also, I can say that DF is equal to BC, because opposite sides of parallelogram are equal. So thus DE is equal to DF is equal to BC. Sorry. Now I can also say that DE is equal to EF also. D is equal to EF, because here it is given also. So D is equal to EF. So therefore, in this equation, I'm going to substitute that DF is equal to what? DE plus EF, right? Because see, DF is made up of DE and EF, right? So now let me just wind the theorem up here. I'm writing it in this space. Don't worry, I will name wherever I'm writing it. In parts I've written, I will write that, don't worry. See, so DF is equal to DE plus EF, and I know that DF is equal to BC also. DF, where have I written that? DF is equal to BC also, I've written here. So therefore, since DF is equal to BC, then 2DE is equal to BC, right? 2DE. How can I say 2DE is equal to BC? Since DF is made up of DE and EF, and DE and EF are equal to each other, so can I say that instead of DE plus DE is equal to BC, I can say that 2D is equal to BC. How did BC come here? Since DF is equal to BC, instead of DF, I'm writing BC. Are you understanding me? See, I'll write it in better ways. Wait. Let me write it step by step, or else you'll be confused surely. I think this step is a bit confusing. Let me write it for you properly. Wait. So I said that DF is equal to DE plus EF. So instead of DF, I'm writing BC here. Why? BC is equal to DE plus DF. Why am I writing BC here? Because DF is equal to BC. So instead of DF, I'm writing BC. Okay. And also you know that BC is equal to DE plus DE. Why? Because DE is equal to DF. You can see DE is equal to DF. So instead of DF, can I write DE? Yes. So BC will be equal to DE plus DE is 2DE, right? So 2DE is now equal to BC. Now let me just bring this to the LHS side. So that will become half of BC is equal to DE, right? So that is DE is equal to half of BC, correct? Now, what did we have to prove in the question? That DE is parallel to BC. I proved that DE is parallel to BC, and I also proved that DE is equal to half of BC. That's how we proved this theorem. Do you guys understand how we proved it? This is how we proved this theorem. Easy. Okay. Now let's move to the next theorem. I hope you guys got it right. Cool. Now, moving on to the next part. Which ink do we use? I think orange will be nice combo with pink, right? Hot pink, yeah. Okay, so let's move on to the next theorem, which is the last theorem of this chapter as well as this video. So the last theorem is theorem 8.10. What does it say? The line drawn through the midpoint of one side, the midpoint of one point of one side of a triangle is parallel to another side, which bisects the third side. So what is it saying? I know the statement is a bit confusing. So let's just draw the figure. I have a triangle A, B, C. I have a triangle A, B, C here. Now, the line drawn through the midpoint of one side of a triangle, let's say that midpoint is F here, okay, for side AC. Okay, let's say let's not take F, let's take E. Okay, leave F. We'll say E is the midpoint of AB. Okay, so E is the midpoint of AB according to the statement. Midpoint of AB. Okay, so now we are going to draw a line through the midpoint of AB. Okay, we're going to draw the line like this. So the line drawn through the midpoint of one point of one side of a triangle is parallel to the other side. Okay, meaning EF is parallel to BC, right? EF is parallel to BC. Through one side of a triangle parallel to another side bisects the third side, meaning it divides AC into two halves. So that means AF is equal to FC, that is F is midpoint. That's what the second half of the theorem is saying, right? So this is what the statement explains. Now let's see how to prove this. Now given is E is the midpoint of AB and EF is parallel to BC. Now what do we have to prove? We have to prove that AF is equal to FC, that is F is the midpoint. Clear? Now for this we are again going to do a construction here. Construction. First we need to extend F, extend C such that they meet one second. Yes, such that they meet at point G. Now CG is we have to CG which is there is parallel to B. Okay, that's how we have constructed this according to the question. Let me draw this in another ink so that you'll know that this is a constructed one. Okay, so by construction we can say that what? Extend F and C such that they meet at G and G CG is parallel to BE. By construction, we're saying this. Clear? Now let's see the proof to this, shall we? Of course. Now, what is the proof here? First, we're going to see that EG is parallel to BE, right? EG is parallel to BC, given. Where is EG? EG is parallel to BC. Okay, so we are not considering EF is parallel to BC. EG, okay, EG, the line drawn through the midpoint of one side of a triangle. See, go to the statement, the line drawn through the midpoint, not at the midpoint, but through the midpoint, meaning the line is not stopping at the midpoint of one side. I mean, I'm so sorry, I'm explaining it wrong. Okay, so sorry. I mean to say that EG is parallel to BC, okay, according to what is given. Okay, I'm so sorry. I think I confused you guys. Real sorry. EG is parallel to BC because the line drawn through the midpoint of one point of a side of a triangle, meaning from point E, whatever line is drawn, is passing through the point of AC. That is, it is passing through F and it stops at G. Okay, so EG is parallel to BC. Okay, and so therefore we are writing that EG is parallel to BC given, and BE, which is there. Okay, BE is also parallel to CG by construction. Because of construction, I'm saying that. So therefore here you can see that in this quadrilateral, which quadrilateral, let's take a highlighter. B, it's not working. Okay, BE, BEGC, BEGC, this quadrilateral, we are saying that what? It is a parallelogram. Okay, this quadrilateral, it is a parallelogram because you're saying that the opposite sides are parallel to each other, right? So therefore, BECG is a parallelogram. Clear? Now, moving on. So we said that BEGC is a parallelogram. Now, in a parallelogram, we know that opposite sides are equal. So BE is equal to CG as well as AE. AE is equal to BE. Why? Because E is midpoint. Okay. So BE is equal to CG because well, opposite sides of parallelogram. Okay, and also I can say that CG is equal to what? AE. Why can I say CG is equal to AE? Now since BE is equal to AE and B is also equal to CG, can I say that CG is equal to AE? I'm substituting AE instead of BE, right? So let's say this is equation number 1. Now we are going to take triangles AEF. Look at the figure, AEF and FGC. Okay, two triangles, AEF and FGC. AE is equal to what? CG. Why? Because we have already proved it here. Equation 1. So you can say that equation 1, or you can say proved in the brackets. Then let me continue the proof here in writing so that you won't be confused, So AE is equal to CG, I told you. Next, angle AFE. Where is angle AFE? Angle AFE is equal to angle GFE. GFE, that is this angle. Why? Because it is vertically opposite angles. And also angle EAF. Where is angle EAF? Angle EAF is equal to angle GCF. GCF. Here you can see it is a alternate interior angles, right? So alternate interior angles. So therefore, which congruency rule can I use here to prove that these two triangles are congruent? By angle side. So by AAS congruency rule, triangle AEF is congruent to triangle FGE. You may ask me why we are proving that they're congruent. Wait, look here. Because by CPCT, I'm going to say that AF is equal to what? CF. See, so far all the steps that I did before proving that these two triangles are congruent were to actually bring uh, the sides or the angles to be equal so that I can prove that they are congruent, right? So that's why I did all these steps before saying in triangles AEF and FGC. Clear? So by CPCT now I can see that AF is equal to FC, and therefore what we had to prove in the question, AF is equal to FC. This is what we had to prove. So therefore, thus F is midpoint of AC and proved. Clear? So this is how we prove this theorem 8.10. Did you guys understand? Did you guys understand this? Yes, I hope you guys got it. I believe you do. So that's it, guys, for this video. This one was quite short, right, compared to my other videos. But anyways, I hope you guys understood it. If you have any doubts, please feel free to use the comment section down below, and please type out your queries and everything which you want to ask in the comment section below. And if you found this video helpful, please make sure to like, share, and subscribe. And please make sure to check my channel out for more such fun videos. Not only math videos I make, but I also do other videos, other fun stuff. I sing songs also. I'm into music, so you can check that out as well. So many more other things are there. I won't reveal all the secret to you. You check it out for yourself. Okay, so that's it, guys, for this video. See you all in the next session, and till then, take care of yourselves, and bye bye.